Good morning, I'm Mr. Precella with my favorite college algebra class, and we're going to work some of the problems from the final exam review for all the people that are knocking off early for Thanksgiving break. I'm sort of surprised there's so many people here. Anyway, I think we'll just start at number 1 and see how far we get today, and then when class is over I'll upload this video and put it into my math lab as an ungraded homework assignment, so for the people that are missing it. Number 1, find the value of the determinant. This is a 3 by 3 determinant, and you'll notice I've recopied the problem for us already. So what's the trick for finding a 3 by 3 determinant? Okay, so I'll repeat those first two columns. That's a -5, 3, 3, and 3, 2, 5. And then we're going to have 3 products falling from left to right minus 3 products falling from right to left. Okay, here we go. Start in the upper left hand corner, multiplying down. -5, -5 times 2 times -2 gives me 20. Okay. 3 times 4 times 3 gives me 36, I agree. And 5 times 3 times 5 gives me 75. Now we have 3 products falling from right to left. We pick up here at the same spot. 5 times 2 times 3, 30. -5 times 4 times 5, -100. And 3 times 3 times -2. Simplifying inside the parentheses, 20 plus 36, that is a 56. 56 plus a 75, is that a 141? 131 minus 20 minus 70 is 20 minus 100 is a -70, minus 18, that's a -88. And 131 minus a -88, that's going to give me a positive 219 for response D on the review sheet. A word of warning: if you forget and go start the diagonals from right to left, minus from left to right, you'll get the wrong sign. You'll incorrectly get that -219, so be careful. That's not that much of a problem with 3 by 3 determinants, but with 2 by 2 determinants it is a problem. People start multiplying at the wrong spot. So moving on, number 2, let's see what it says first of all. I warned you all when we were doing Cramer's rule that the test would have problems designed to make sure that you know how to use Cramer's rule, and that you can't just use elimination and substitution on your homework, because the test will be assessing your knowledge of Cramer's rule. Number 2, they don't even give us the system of equations. All they do is give us 3 different determinants. They tell us D is equal to -2, D sub x is equal to 10, D sub y is equal to -12. And then they say, find x and y. So here we are, number 2. Well, we know from Cramer's rule that x is equal to D sub x over D. So that's a 10 divided by -2, which is -5. By Cramer's rule, y is equal to D sub y divided by D. So that's a -12 divided by -2, which gives me a positive 6. So these two lines, whatever the lines are, they didn't give us the equations. We know that these two lines are going to intersect at the ordered pair -5, 6. -5, 6, that looks like response A on this review sheet. So, number 2 is trying to determine, do you know the relationship between the respective determinants and the solution to a linear system? Number 3, okay, it's designed to see, do you know how to find the respective determinants? Notice on number 3, they say use Cramer's rule to find d sub x. And I've recopied the problem here a little bit bigger because I like to write so big. X minus 3y equals negative 16. 5x minus 4y equals a negative 47. And here they're asking us to find d sub x. Okay, so d sub x, it's a determinant. It's a determinant. What numbers will be in the first column of this determinant? No. Okay, for d sub x, that means the x column is replaced by the column of constants, negative 16 and negative 47. They're not asking you to find d, dx, and dy. They're just asking for one specific determinant. In this case, they're asking for d sub x. What numbers are in the second column? Okay. And these 2 by 2 determinants are where people make the mistake of multiplying the wrong direction. You always start in the upper left-hand corner. You always start up there, whether it's a 2 by 2 or a 3 by 3. And there's only 2 cross products. Here, 64 minus there, a 141. 64 minus 141 gives us a negative 77, and that's all they're looking for. Now suppose they'd asked for d sub y. They didn't. They just said d sub x, but it's assumed if you can find d sub x, you would know how to find d sub y. So if it had said d sub y, what would be in the first column? 1, 5 would be in the first column. In the second column, we'd have okay, whatever the subscript is, that's the column that you replace with the column of constants. Any questions there? Oh, and by the way, that negative 77, where is it? Looks like it was response C. And number 4. Okay, number 4. It says write the binomial expansion of the expression negative 2n plus 4n raised to the 4th power. That writing's really small. And they want us to determine what is the third term. They're not asking for the entire expansion. They're only giving us the third term, or they're only asking us to find the third term. What should we do first with the binomial expansion? Okay, that little Pascal's triangle is what we were using to get those coefficients. Pascal's triangle. The first number, each row starts and ends with 1. The row number tells us how many numbers we have in each row. So row 1 has 1 number. Row 2 has 2 numbers. Row 3 is going to have 3 numbers, but to determine that missing number, we add the pair of numbers immediately above it. 1 plus 1 is 2, and that's why you called out 2. Oh, by the way, before we go on number 4, the exponent outside the parentheses is 4. And on number 5, we're going to do that one in a moment. The exponent is 5. How far do we have to go?
5.
Until we get the second number to be what? A 5. So I'm going to only go as far as I need to go to do these 2 problems. So here we are. We're on row 4. We need 4 numbers. We already have 2 of them. To get the other 2, add. Row 5, we need 5 numbers. We've got the first 2, 1, 4, 6, 4, 1. And I think this is as far as we need to go in order to numbers 4 and 5. 1, 5, 10. 10, 5, 1. Now I'm going to set this aside because I'll be needing that in a moment. Well, I'll be needing it for not only this problem, but number 5 in a moment as well. So there. First thing we do, we write down the coefficients. I'll write them down vertically. Which numbers will be my coefficients? 1. 1. Go to the row whose second number is equal to the exponent outside. 1, 4, 6, 4, 1. Then we take negative 2m to the fourth power. Okay, so we start sweeping down, decreasing the exponent. Cube, square, first, and finally no negative 2m's. What do we put down here beside this bottom one? 4n to the 4. Then we sweep up 3, 2, 1. Oh, and finally no 4n's. They want us to determine the third term. So I'm not going to simplify the rest of them. I'm only going to simplify the one that they want. 1, 2, 3. Here's the third term. This is the one that I'm going to simplify. Remember, you should perform exponentiation before multiplication or addition, subtraction, what have you, for your operations on real numbers. So what should I do first? Negative 2 squared, that is a positive 4, okay. Here's my scratch work. I have a 6 times. I said that's a 4. That's a positive 4. Anything else? 16. And let's see, is that a 384? Someone check me there.
Yes.
That's a 384. Now the variable part, m squared, I agree. Anything else? And n squared. So 384 m squared n squared. 384 m squared n squared. Let's see. And it was a positive. Here it is. 384 m squared n squared for response D. Any questions there? Okay. Are you using your calculator? You got to enclose that negative 2 in parentheses. Otherwise, your calculator, if you're punching this in, if you're punching that into your calculator and it's not enclosing the negative 2 in parentheses, all you're doing is squaring the 2 and then changing the signs. Remember, exponentiation is performed before multiplication. So without the parentheses, but my advice to you is don't forget what you already knew. Negative 2 times negative 2. You could do that in your head without a calculator. So write it down like that. 6 times 4 times 16. Do the stuff that you can do in your head, taking care of the signs automatically. And number 5. Number 5, it's another binomial expansion. So, number 5. And you'll notice on number 5, where is it? Number 5, they're asking what is the fourth term. We're still going to go through the same process, but in this case, we'll simplify the fourth term. I need my coefficients. What would be my coefficients?
1, 5, 5.
Okay, so looking at the triangle, you go to the row, since that exponent is a 5, you go to the row whose second number is a 5. I agree with the 1, 5, 10, 10, 5, 1. So here we go. 1, 5, 10, 10, 5, 1. I better spread those things out. Let's see what's going to happen in a moment. What do I put beside the top one?
-4.
I take the -4. Anything else? To the 5th power, and then I start sweeping down. -4 to the 4th, -4 cubed, -4 squared, -4 to the 1st, and finally no -4s.
We do y/2 to the 5th.
Okay, then I take that second term. Notice that's a positive y/2 to the 5th. I remember y'all doing a problem like this in the homework on Monday, if I remember correctly. There was one like this. I think it was the last one, binomial expansion problem in your, wait a minute, 5, what did I do? That should be a 4, 3, 2, 1, and finally no y/2s. And which term do they want us to simplify? 4th, okay. 1, 2, 3, 4. Here's the 4th term. That's the one we're going to simplify. And if I remember correctly, what I did, I would break this into steps, and I would break it, deal with the fractional factor first. I deal with that denominator. I draw my fraction bar. I'd say 2 cubed. 2 cubed is 8. The variable part, y cubed, I'd write out on the side, y cubed. The other constant factors, they're not in the denominator. That means I'll be putting them in the numerator. What am I going to have here?
160.
Okay, -4 squared is a 16. A 16. And 16 times 10, I agree, that's a 160. That's a positive 160. And we can simplify that sum. 160 divided by 8, that gives me a 20 y cubed. That is a positive 20 y cubed. So when we look at number 5, a positive 20 y cubed, that looks like response A. Any questions there? The first step for these binomial expansions, though, is to do what? No, for the first step, first thing we did for these. Write the triangle, okay? So don't get addicted to just looking at the triangle. Make sure that's already been written. Make sure you know how we wrote this triangle, because you'll have to do that before you do the rest of the problem. And then number 6, we're going back to old material.
How many questions did you say were on the test? I'm sorry.
I'd say about 30.
30.
I'm saying about 30. I don't recall exactly, okay? But I think it's about 30. Ask me on Monday or Wednesday, and I'll tell you. So, solve the equation using the quadratic formula. Well, let's see. I've written it down here. 4n squared equals a -10n minus 2. If we're going to use the quadratic formula, what should we do first?
Write the quadratic formula.
Okay, let's write the quadratic formula. Recall the quadratic formula. Instead of an x, we have an n equals, it's -b plus or minus the square root of b squared minus 4ac all over 2a. So we recall that quadratic formula. And what else should we do? Okay, we need everything set equal to 0. I like my leading coefficient to be positive, so I'm going to move the other two terms to the left. That'll give me a positive 4n squared. That'll become a plus 10n plus 2 is equal to 0. And I noticed something about the coefficients. What do I notice? They're all divisible by 2. So we can multiply through by 1/2. That'll shrink down the numbers. If we don't do this, once we use the quadratic formula, we'll still have to simplify. We'll have a common factor of 2 that we have to factor out and cancel. So we may as well simplify it right now. Multiplying 3 by 1/2 is the same thing as just dividing by 2. 4 divided by 2 gives me a 2n squared plus 5n. 2 divided by 2 is 1, and 0 divided by 2 is 0. Notice, if this were a function, if we were asked to graph f of x equals 4x squared plus 10n plus 2, we couldn't do what we've just done. You can only do this to an equation, the way we're getting rid of that common factor. Identifying our a, b, and c values, we have a equals, b is equal to, and c is equal to, and substituting into our quadratic formula, okay, so we have n equals, that's a plus minus square. Okay. Okay, so what did y'all say the opposite of b? The opposite of 5, I agree with the negative 5. Plus
or minus 5 squared.
Which is
25.
25. And remember the minus 4 times a times c, I think all semester long I've been saying I'll just do that on my scratch paper, which is my other way of saying I just do it in my head. Negative 4 times a times c, what's that going to give us? So minus 8 all over a denominator of 2 times 2, I agree with 4, and so we have a negative 5 plus or minus 25 minus 8, that's 17. Can we simplify the square root of 17? No, 17 is a prime number. If we hadn't gotten rid of that common factor of 2, you would have wound up with a 68 there. You would have had to take out rewritten it as 4 times 17 and then taken the square root of 4. You would have had a negative 10 there. You would have had an 8 there. You would have had to factor out the 2 and cancel. So getting rid of the common factor saved us from reduction there at the end. This is number 6, A, B, C, or D. Let's see, number 6. Negative 5 plus or minus the square root of 17 over 4. I agree, that looks like response B. Number 7. Number 7, solve the equation. And I've written the problem larger here. Negative 5x squared minus 6 over x. Let me make sure I didn't miscopy it. I've been very consistent. When I've run into equations containing fractions this semester, I've always done one step first. What did I do? Okay, so in this case, the only denominators appearing are x minus 4, and necessarily that'd be the least common denominator. It's the only denominator. So we multiply 3 by x minus 4, and we're going to distribute there, there, and there. What are we going to have here on the left side of the equal sign? Okay, the x minus 4s are going to cancel, leaving us just a negative 5x squared minus 6 equals here. Okay, the x minus 4s are going to cancel again, leaving us just a negative 15x. What's going to cancel here? Nothing. You're going to have to distribute that 6 to give me a plus. Minus 24, I agree. And it's quadratic. I see that x squared. It's quadratic, so that means one side needs to be 0. Let me ask you something. What do you think I'm going to do? Am I going to leave the x squared term on the left, or am I going to move it to the right? Move it to the right, because I like that leading coefficient to be positive. So I'm going to get 0 on the left. Moving the x squared term over, I have a positive 5x squared. Negative 15x plus 6x, that gives us a negative 9x. Move the 6 over, combine it with the negative 24. What's that going to give us? Negative 24 plus 6, I agree with that, negative 18. And the instructions don't say use the quadratic formula. It seems to me like with my math lab, with the Pearson products, if the instructions don't specifically say use the quadratic formula, when you're trying to solve a quadratic equation, it's probably factorable. So I'm going to try to factor it. 5x squared, that's not bad. There's only one pair. 1x and 5x, okay. And 18, you could have a 1 times 18, a 2 times 9, or 3 times 6. 3 and 6, okay. Playing around with the possibilities in our head. Oh, and I forgot to ask you, what do we know about the signs inside the parentheses? Okay, because of that negative sign there, we need one positive, one negative. Let's see, does this do it? A negative 3 and a plus 6? Is that doing it?
Yes.
The outer product is negative 15x. The inner product is a positive 6x. And yes, that gives us the negative 9x that we need. So now what do? Set each factor equal to 0. And that's going to give us either x equals 3, or here x equals negative 6/5. Now, when solving an equation containing a fraction, remember, fractions aren't always defined. What number would have been unacceptable as an x value in this problem? Positive 4. You don't want the denominator to be 0, and the only number that would make those denominators 0 is 4. Did we get 4 as an answer? No, so these numbers are perfectly acceptable. So we want a positive 3 and a negative 6/5. Positive 3 and a negative 6/5, that looks like response C. Any questions there? Number 7. Number 7. Oh, number 8, right. Yeah, number 8. Solve the inequality. Notice the instructions here. You know something, this is a good time to take a break. So I think I'll take a break for a moment, and then we'll continue with this.